Okay, once again, okay, do we have any questions about why we have print question mark? No.
Because you don't know the value of the invoke.
Yep, the question mark is a placeholder for the return value of invoke relay, 2 goes to n. By the time we execute line 3 of the pseudocode, line 3 is returning n. N equals to 2, so we are effectively returning a value of 2. When we return any value, we are copying and pasting the return info cell and just replace the question mark with the value that we are returning. We're basically resolving what is invoked relay, blah, 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 and it turns out to be just the value of 2 in this case. Yep.
But why n is 2 again if this first column was disposed?
Why are we destroying, are you talking about row 12, why we are destroying or deallocating column D and column E?
Why the second one, the n is 2 again after we disposed rows 5 to 8?
Are you talking about row 8, why we are deallocating?
So we dispose this all including n equals 2, so why is n equals 2 on lines 9?
Over here?
10? Yeah.
Because this is new, because we are executing this line on line 6. When we get back to line 6 of row 9 of the trace, we are executing the statement as described by D7. And as a result, we have to pass 2 to n again when we invoke relay. We are basically resolving the invocations of a subroutine to a value every single time. But I can only resolve one unknown at a time. So that's why I have to resolve the inner invoke first, and then I move out to the outer invoke. Okay, is that okay so far?
Because you're within a subroutine. It's not like n's a global variable.
N is a parameter of relay.
Within the subroutine itself.
Exactly. So when I get out of the subroutine, I have to deallocate that column.
Right.
Is there a purpose to the 5 out and
Yes, because this is the only way for me to get information into a subroutine. So in this case, the subroutine doesn't really do anything useful. All it does is to return the same value that you give it by value. But it's just for a demonstration. In this case, what do we do when you have the result of one invoke to specify the parameter of another invoke? Are we doing okay with this one? Okay, if we're okay with this one, then I'll go ahead and save it, and then we'll talk about factorial again. So this time, we are seeing factorial the second time today, and this time it is using the concept of returning a value. And we'll call this one invoke in invoke, which is a little bit confusing, but hopefully it's not too bad. And this time we have factorial, define sub factorial again, and this time it only has a single bi-val parameter n, because we want to compute n factorial. So that's why we need to pass that number in to work with it. Then we say if n is less than or equal to 1, then return 1. Else return, now this part is interesting, we're going to return n times invoke factorial. N minus 1 will be used to specify parameter n. And define sub. This is by far the simplest definition of the factorial subroutine. I missed one and if line, I will fix that later. Like that. And then we have our usual define sub main. I'm just going to print the value of 3 factorial. So we'll invoke factorial using 3 to specify n. And that's my main subroutine. And here's my entire program. Okay. So the only difference this time compared to last time, well, there are several, but line 6 is the key, okay? Because line 6 is kind of interesting, even from the static perspective, it is kind of interesting. We know how to do with n times the invocation of something, because that's what we have been dealing with the previous two example programs. But this time, it is not just invoking anything, it is invoking factorial itself. It is recursive. Okay, the subroutine is calling itself. But we already know that a subroutine calling itself is nothing new. All we have to do is to use exactly the same mechanism as with any subroutines. Then we should be fine. The confusing part of line 6 is when we are returning, we'll be specifying a return value of a return statement. Okay, so we'll take a look at that because that part can certainly be confusing. And there's a reason why I pick all the confusing code to use to illustrate the concepts. It's because if I use a simple example, everybody gets it, no problem. I cannot tell whether people truly understand the nature of the mechanism. Okay? If I use a more confusing example like this one, then it will expose any type of misunderstanding of the concept. And that's good. Okay? Because if we discover that we have a misunderstanding of a mechanism in this class, I can address that. Okay, I can basically try to explain it again using another example and so on and so forth. So by the time you move on to cisp360, your understanding of the mechanism will be correct. But if we don't do that, and people use a people move on with a misunderstanding of a concept, by the time you get to 430 or 440, it becomes much more difficult to undo. Because at that time, those people with a misunderstanding would have been using the
Incorrect method. Incorrect method.
The incorrect understanding for so long, it becomes difficult to switch back to the correct understanding. So we'll take a look at this one. This one is definitely not one of the easier ones, but it is a good way to to demonstrate and to expose any type of misunderstanding of this concept. The first time I taught this class, I got tripped by a few times too. So don't feel bad if you feel this is kind of difficult, because it is a little difficult and confusing. We need the comments column in this case because we definitely have a condition to evaluate. We have line number. Precondition, nothing to say because we have no global variables anymore. And we'll start execution on line 12. It is invoking main. By the time it returns, we will use a return line number to tell us to go back to post. So there goes the easy part. Then we go to line 10, which is the first line, the first action of the main subroutine. And this by itself doesn't look too bad. Okay, we just have to specify a return info and also one column for parameter n. Parameter n is easy to specify this time because all we are doing is to use the expression 3 to specify the initial value of n. N starts with a value of 3. That's not too bad. Return info is telling me where to go back to and how to continue on that line. In this case, when I'm all done with line 10, we have to go back to line 10 again because the print still has to happen after the invocation of factorial. As a result, we'll say by the time we return, we just go ahead and print whatever factorial returns. Are there any questions at this point about how column D and column E are set up? Now, at this point, this program is actually easier than the other two programs that we have seen already. Because the first program that we have seen has invoke 7 and invoke woo on the same line. So from that perspective, we have two invokes on the same line. The second program has an invoke inside an invoke, which is also more complicated than this one. So this one, as it turns out, is actually simpler than the other two programs, at least at this point. Are we doing okay so far with this? Okay. So now we are ready to go into the factorial subroutine, starting on line 3. Line 3 is the first action line of the subroutine factorial. Doesn't really do anything that's too interesting. It's comparing n to 1, n is 3, 3 is less than or equal to 1 is false. Okay, so that's not a big problem. We go to the else portion and we execute line 6. Line 6 is a return statement, but I can't really execute the return statement unless I know what value I'm supposed to return. I don't know what value I'm supposed to return until I know what the invocation of factorial is going to return. So that means I have to invoke factorial again from line 6. Is that okay so far? Because to resolve what value I have to return, I have to first invoke factorial. Then I can go through the multiplication and return the product of the multiplication. So that means I have to invoke factorial again. I have to set up another column for return info, another column for n. Let's deal with n first. What should I put here in column G? 2. It is 2 because when you look at line 6, it uses n minus 1 to specify n. The n minus 1 or the n of n minus 1 on the left-hand side refers to column E, which is the context that I'm in at this point. 3 minus 1 is 2. As a result, G, column G, starts with a value of 2. Okay? This part is the same as the earlier example that we have seen so far. What is interesting, or actually not interesting, is about the return info. What do we do to specify return info? We pretty much copy the entire line, in this case of line 6, except the invocation of factorial itself is replaced by a single question mark. Right? That has been the way we do, we invoke subroutines that return a value. So in this case, we just have to say the return info tells us to go back to line 6 because there are additional things on line 6 that I have to do when I return from factorial. And that, namely, is just return n times the result of the invocation. The invocation itself is replaced by a single question mark as a placeholder of its own return value. Is that doing okay so far? Because if we need to stop, this is a good place to stop and talk about why return info is set up this way. Yep.
So this line, the last one, we have the value of n equals 2. So why won't we replace this 2 in this return info column?
Because we are not talking about we'll see later. Okay? Yeah, that's a good question. Save it in your mind first, because by the time we start to return, that question will be answered. Okay? Any other questions?
Yep. D6, shouldn't you have a 10 colon in front of print?
D6, right here? Yes, I should have made a line number here. Thank you. That was a oversight of mine. Thank you. Anything else? Are we good? Okay. So where am I going now? I'm invoking factorial again. So that means I have to start from the beginning of factorial at this point on line 3. Line 3 is doing the same thing and is less than